Welcome everyone to our notes for our future forgetful selves in lesson 3. This is where we're describing linear patterns algebraically. The goal is for you to be able to say, I can represent the rules for some patterns algebraically and explain why doing that is helpful. Let's have a look at our first example. We're going to get straight to the examples on this one. And it says, Mr. Squatch played a game with 2 friends one night. On the next night, 2 more friends joined. The night after that, 2 more friends played as well. How many were playing on the 100th night? Now the way I'm going to start is by labeling our terms. This is the first term, the second term, and the third term. The next thing I'm going to do, in order to get this into an algebraic expression, is to make our table of values. And in this case, I'm going to say that our term number is going to be labeled n. We're going to label our term number n. So this is where our 1, 2, 3, 4, and 5 will go. Next, we're going to put our values over here on the other side of the t-chart. So I'm going to put this in red. We had 3 friends playing on the first night. According to the picture, we've got 5 friends playing the second night. We've got 7 friends playing the third night. We add 2 more and 2 more. There is our pattern. Now we need to put this into an algebraic expression. How do you do that? Well, one thing I can do is I can look at what is a constant across all of these terms. And what I can see is Mr. Squatch is always there. Here's Mr. Squatch in the first term, in the second term, in the third term, and I can bet that he's going to be there in the fourth, fifth, and so on. All of the terms are going to have Mr. Squatch. Then I can see what's variable. Well, I can see that the rest of them are just groups of 2. Here's one group of 2, then 2 groups of 2, and 3 groups of 2, and I think we can see the pattern happening. But I don't know if you noticed this, but this is 1 group of 2. This is 2 groups of 2. This is 3 groups of 2. What we can see is all of these terms are n groups of 2. So we can write it like this. The first term is just 1 plus 2 times n. Okay, this is how you write 2 times a number in algebra. You just put the number next to the letter. The letter represents the term in this case. So we're going to rewrite it again. We're going to say 1 plus 2 times, and then we're going to substitute, instead of having the n, we're going to substitute what term we're talking about. So in this case, we're talking about 1. Okay, now we do BEDMAS and we make sure that we're doing the multiplication first, right? First brackets, then exponents, then division multiplication, and so that comes before any addition or subtraction that we're doing. So we write 1 plus 2 times 1, which is 2, and that comes out to 3. Let's see, can we do the same thing for the next one? If we have 1 plus 2 times n. Well, in this case, we would substitute. This equals 1 plus 2 times, in this case, the n. In this case, the n should be 2. So we're going to put a 2 in there. Okay, let's work it out. It's 1 plus 4. 2 times 2 is 4, which gives us 5. And if we look over here, what was our first one? It's 3. Our second term was 5, and that's what we find right here. It looks like this one expression should fit all of them. Let's just double check to see if it fits for this last one. 1 plus 2 times n. Let's see. If we write it out, it goes 1 plus 2 times 3. And we'll write it out one more time. 1 plus 6, 2 times 3 is 6. That should be 7. And there we go. It works out. Now we should be able to do this even without having the pictures. If we looked just at the table of values, how could we find an algebraic expression that would represent this pattern? Well, let's have a look at how this pattern is growing. When we look from here to here, we can see that we're adding 2. From one step to the next, we're always adding 2, right? I hope that we can all see that. Now, one way that we can figure this out is we can look at this and see what could we multiply this by to get close to this. What could we multiply n by to get close to our number? Okay, I see that if I go 2 times 1, I'll get close to this, and then I can just add another 1. Let's see if that works. Okay, so I'll go 2 times n plus 1 and see if that works. Does that work for the next term? Let's see. 2 times 2 is 4 plus 1. Does that give me 5? Yeah, it does. Let's try one final one in our heads and look at the n equaling 5. So if n is 5 here, 2 times 5 is 10 plus 1 is 11. Is that what we get here? Yes, it is. I can be fairly confident that this is the algebraic expression that describes this pattern. That helps us answer this final question because, if we remember, it's on the 100th night that we want to know. So how do we figure out, how does that help us? Well, again, we'll go over to the side here and we'll see, actually we should include this. If 2n plus 1 is our expression, all we need to do is substitute 100 for the n. So if our n is 100, what goes here? So what I can do is I can write down 2 times 100 plus 1, and then I can rewrite it underneath. 2 times 100 is 200 plus 1, and I write it up finally as 201. And the final thing that I would write is this. There would be 201 players on the 100th night. Now before we go, we're going to look at one more example to show you how you might do this. Alright, so Ms. Unicorn had 301 comic books in her library. Every day she added one more book. How many books did she have on the 25th day? Well, usually when you're trying to figure out a question like this, you want to put your information into a table of values. Okay, that old handy T-chart. Again, we're going to put n over here on the left. That's our term numbers. Okay, and then we put our term values over here on the right. So on the first day, she had 301 books. Then she would have added one more, and then she would have added one more, and so on. So each time we go from one term to the next, we are just adding another book. So last time we tried multiplying this number by something to find this number. Last time it was 1 times 2. Let's see if we can multiply 1 times 301 to get 301. So I might write 301 times n and see if that works. Well, if I substitute 1 for this n, I would get 301 times 1, which would be 301. And that works. We get that number there. But let's see what happens when we put in 2 for this n. 301 times 2 is 602. Does that get us our correct answer? No, it doesn't. So that can't be our algebraic rule. So let's try again. What if we were to just take, well, something that I'm noticing here is that this 1 is the same as this 1, and this 2 is the same as this 2. What if we just did 300 plus n, right? We have 300 plus the number 1, and here we have 300 plus the number 2. So what if we just did n plus 300 and see if that works? It looks like it works to me. If I substitute the n for a 3 and go 3 plus 300, that gets us 303, and it works for 1 and 2 as well. So now we got to figure out what happens on the 25th n, right? On the 25th day, all we need to do is substitute this n with a 25. So we take this 25 and we put it right there. So n plus 300. we substitute the n for 25. So we get 25 plus 300, and we will get 325. Finally, I'll end with a sentence like this. On the 25th day, Ms. Unicorn will have 325 comic books. Now, if you got lost at any point or were feeling confused, don't feel bad. That is normal. This is a tricky one to wrap your head around, and it requires a lot of practice. You can always come back and rewatch this to see how you can get your algebraic expression from your table of values or your t-chart. And I will provide walkthroughs for you on the assignments so that if you get stumped, you don't have to stay stumped for too long. That's all for today. Thanks for watching.